The human brain continues to develop right throughout childhood, right throughout adolescence, and into early adulthood. We see a very significant increase in cerebral white matter volume. So white matter is found in the center of the brain. It comprises these long fibers which connect up different brain regions together. And what you can see here is how it increases. White matter volume increases by about 1% annually during adolescence. Cortical grey matter shows a different pattern. It shows this non-linear pattern of development where it increases during early childhood, it's highest in late childhood, and then it undergoes this very substantial decline during adolescence. Grey matter volume decreases by about 1.5% annually during adolescence. And it doesn't do that across the whole cortex uniformly. What this video shows is that some regions, like the back of the brain, develop before other regions at the front of the brain. It's one of the regions to develop latest in humans, and the prefrontal cortex is responsible for all sorts of high-level cognitive functions, and they include things like self-regulation, decision-making, planning, thinking about the future, self-awareness, creativity, exploration, all sorts of things. Why does grey matter decrease and white matter increase during adolescence? We think that both these patterns of brain development, at least in part associated with increased myelination and increased axonal growth. There's also some synaptic reorganization during adolescence. Now, the important thing about all of these processes is that they're partly dependent on the environment that the child is growing up in. So in that way, adolescence is characterized by heightened neuroplasticity. That is the way the brain adapts to its environment. And that can confer both opportunity for things like learning and rehabilitation, but also vulnerability, because some environments can be stressful.